Hi, I'm Safin, and today we're going to be talking about a broad overview of approaching critical services on Linux. This completes the two-part mini-series on services. We're going to be talking specifically about critical software that's required for company use and it's often mandated for installation and hardening in cybersecurity competitions, as well as the real world. This presentation is going to be a bit different than the ones we previously covered in this channel, as it's more of really a general overview of how to approach critical software hardening rather than hardening a particular software. But stay tuned throughout the entire presentation because it will definitely be extremely meaningful as you take on new services in any cybersecurity competitions. One thing that I do want to mention, however, is the creation of this new Linux Visually Discord server that I made, and I'm going to link it in the description. But basically, you guys can ask questions about some of the existing content I made, request ideas for new content, and even talk about any other Linux-related ideas. And it's just going to be sort of like a safe space to do that. So I highly encourage you to join up and communicate with me, as that would help me make better videos. But yeah, going back to the actual content. So let's first outline the goals of this presentation. By the end of this video, you should have a good idea of what a critical service really is. You should also understand the common attack vectors for these critical services, as well as common security measures to counteract them. You should be ready for pretty much any critical service that you encounter. First, let's talk about what a critical service actually is. You might have heard it quite a few times from your peers or in cybersecurity competition scenarios. Really, the core idea of a critical service is that it's some sort of software program. Typically, this would be packaged as a binary executable and installable via a package repository, and this software would be serving data to other hosts. When I say other hosts, I essentially mean computers on the internet. Now, this could be a customer all the way across the world from you, or an employee in the exact same room. Note that these services are critical for a company business. And some examples of these are company websites, which could be accessed by customers, databases to store information like usernames and passwords, and even remote access tools like the OpenSSH server, which we explored in a previous video. The key idea is that all of these programs transfer data over some sort of network, typically the internet. And the great thing about input and output over a network is that all of these connections can be sort of verbosely tracked down and analyzed. So I like to think that there's no loose ends for programs in the sense that all communications that occur over the network are sort of tracked and can be analyzed. First, let's talk about the main considerations you'll always want to make when setting up and configuring a critical service, regardless of its actual purpose. We can split up our considerations into two categories. The first being risk mitigation, which is a sort of hardening to prevent attacks, and it includes things like network traffic encryption, access control, and system configuration. The incident response of our considerations should help us if an attack were to actually happen. And really, the only practical thing in the scope of cybersecurity competitions with enforced time limits is setting up logging solutions. And we're going to be going over each of these principles individually in the next few slides. So let's jump in. Let's first discuss the issue of network traffic encryption. We all know what happens when we enter apple.com to our browser bar. I'm actually going to do that right now just to demo it. So I'm going to go ahead and enter apple.com, and we'll see apple.com right here. We'll also see this lock in the top left corner, but what does this lock actually mean? Now, it actually corresponds to the S in the HTTPS portion of this URL, and it means that the network traffic is that transferred is like from Apple's computers to my computer was encrypted and not displayed in plain text, which it would be the case if I were to use an HTTP URL. And this doesn't really matter for the public-facing site that is the Apple homepage, but more sensitive traffic can avoid snooping using this encryption, and that's where SSL and TLS come in. These standards provide sort of a standard for encrypting network connections from devices connected to a computer network. And this is absolutely essential for just about any critical service communicating over the network. And it's pretty much considered a critical facet of the service hardening, especially in real-world companies. TLS is the most up-to-date standard for this and uses a combination of asymmetric and symmetric encryption, which, if you're not sure about, I've linked the previous video of mine where I briefly explained it. You can click on the slideshow in the description of this video to find the link. And it uses these technologies to establish a secure session. Now, as time progresses, new versions of this standard are released. New versions of this standard are released. And old versions are deprecated as they reach their end of as they reach the end of their life cycles. This means that they no longer get support and possibly have vulnerabilities in them. TLS is considered the direct successor to SSL, and whenever possible, should be used where a TLS version configuration option exists. More specifically, TLS 1.2 Plus should be used as previous versions are deprecated. Note that most programs have configuration options for setting up TLS encryption, that have this TLS encryption setup. Also have configuration options for cryptographic ciphers that are being used in the TLS encryption process. Now, similar to the SSL and TLS standard as a whole, these ciphers are often phased out and are replaced with more up-to-date and robust algorithms. Because the TLS process uses a combination of many different cryptographic hashes, ciphers, and more, these cipher suites, such as the one I put on the slideshow right here, they look like this. And I highly encourage you to research up-to-date cipher suites that have the highest levels of encryption for the TLS process. These are just some I pulled from offline. I've linked a great resource that I personally have found really useful when setting up SSL and TLS on critical services called the Mozilla SSL generator, and it'll automatically generate configuration for popular software to use preset cipher suites. It's a great starting point for anyone looking to set up network traffic encryption themselves, but one thing to be careful of when selecting the absolute most up-to-date cipher suites and TLS versions is to be aware of the issue of backwards compatibility. Now, companies need to be able to serve customers who may not be running the most up-to-date hardware or software libraries. Accessibility is king in the business world. The wider your audience, the more potential customers you have, and the more money you can earn. Be sure not to be too restrictive with your SSL and TLS policies so as not to support older clients. It's really up to you to weigh the equally important scales of security and accessibility. An exercise I recommend you do after watching this video is to actually set up a critical service such as Nginx or Apache 2, which are web proxies and servers, and set up SSL and TLS encryption on them. It'll be a good practice researching these configurations and testing them out. All right, let's talk about authentication. Pretty much every tech company's product has some sort of login page. They all support their customers in the ways that they individually choose to. As such, it's important that authenticating users for any critical service is highly scenario dependent. Knowing that, let's hop into some of the common authentication schemes or methods typically supported by services that require users to log in. One of the most used authentication mechanisms is called public key authentication. Sorry about the two bullet points appearing at once. I'm not sure why that is, but let's just focus on this first one. Public key authentication allows fine-grained control over exactly what users can access a server. It's typically used for critical services that provide for employees, since it'd be kind of a pain to set up individual non-technical humans with public key authentication. And I've linked an article right here that goes into great detail about how exactly pub key authentication or public key works. It's sort of a fine-grained analysis of it, specifically for SSH servers. And yeah, I'm just going to move on to password authentication. So password authentication is another extremely common authentication scheme. It typically involves some sort of username, like an email, and a passkey or password that the user enters. It works by using a mathematical algorithm to sort of turn a password in plain text, which hopefully was transmitted over a TLS encrypted protocol, into a hash, which if you're not sure about, I've again linked a great further reading page. It then compares this hash with some sort of database, whether that be the etc shadow file or some other program existing on the system. This method of authentication suffers from the single weak link in all of computing: human error. Poor password hygiene and brute force attacks that come along with them, which are repeated spam attempts to guess these bad passwords, plague password authentication schemes. If your scenario does require password authentication, ensure that strict password requirements are in place so that users are not susceptible to these types of attacks. And this is very important to consider. Kerberos is another popular authentication scheme that involves authentication server existing on the network. Passwords essentially travel over the network to that server and the authentication results are sent back, meaning the user is either valid or not. This is fairly rare in online cybersecurity competition rounds, but is very popular at the industry level in real companies, so just be aware of it. If you're interested in Windows, you may know that the Windows AD and DC software stack does actually support Kerberos authentication by default, but that's just a side note. Finally, PAM authentication is popular. I've already created a really comprehensive video on exactly how PAM stacks work, so I won't go into much detail on this, but I highly recommend that you actually do look into this scheme and the video that I've linked here for your own learning purposes. Note that PAM configuration specifically for a certain service is typically located in etc pam.d and then the name of the service. So for example, for OpenSSH server, it would be /etc/pam.d/sshd. All right, so for root access, it's pretty simple actually. The idea is that you really do not want to let anyone log into your critical service as the highest level root or administrative user. It's simply a bad practice to have this capability even exist, and it's much better to instead ensure that authorized administrators can elevate to the super user administrator using some functionality within the service, like sudo in the case of a remote access tool like OpenSSH server. Finally, within the access control group, that is, anonymous server access. Now, similar to the authentication schemes for any critical service, it's highly scenario dependent. Some critical services, such as file servers, may want to permit anonymous access, but systems with remote access tools, such as SSH, generally should not. You don't really want anonymous access to a company server. It is important, however, to fine-tune the permissions of a non-authenticated anonymous user based on the use case. For example, in the case of a public file server, anonymous access should allow you to read the contents of the server as opposed to being able to write to it, for example, and upload files. These fine-tuned preferences are often present in servers that support anonymous access, and I highly recommend that you configure them according to your use case. Some anonymous solutions even allow you to define a certain password for the anonymous user. So look into that option if it applies for your scenario. Alright, so let's shift our focus to overall system configuration and talk about the daemon. All processes on Linux are tied to the user that runs them. As you can see in this screenshot from the previous services video that I created, I have the cpadmin user running the dash command, and then in another terminal within the process tree, we'll see that the cpadmin user is indeed tied to this dash command down here. Now, background processes spawned by these systemd services are background processes spawned by the systemd services that correspond to critical services are actually referred to as daemons, these background processes, and are associated with users just the same way as any other process really is. If you have no idea what it just said, I highly recommend checking out my last video just to make sure you understand what a systemd service is. But moving on, the processes running as a particular daemon user inherit all of its permissions. For example, all of the files that a particular user has access to. If a background process is running as a particular daemon user that has access to a group of files, that program can modify, write to whatever, do whatever they want to those files, just as the user would be able to from the command prompt. And therefore, logically, it's a good idea to ensure that the user that a particular critical service is configured to run as has limited permissions and avoids root if possible. You can do this by checking the corresponding systemd service configuration file to see the actual user and group the service is running as. And as we just mentioned, Processes are spawned by systemd services, so they inherit the capabilities based on the systemd service configuration file. Again, watch my previous video on systemd services if you're not sure how to configure or analyze granted capabilities. But overall, just be sure to check the corresponding systemd service configuration file for your critical service. So for example, for OpenSSH server, you might be looking at sshd.service or ssh.service, whatever it might be. Alright, so speaking of permissiveness, it's also important to discover actual file system it's also important to monitor actual file system permissions or for files that correspond to a critical service, including its configuration files. Only the superuser should be able to edit service configuration files, and authorized administrators should be able to edit it with the sudo command. As such, you should really ensure that all configuration files and directories are owned by the superuser or are owned by the superuser or appropriate user group as well, and have the correct permissions applied to them to tighten up file permissions as much as possible. It's also important to apply these permissions recursively, to be aware of parent and child directories and or paths. Another class, so to speak, of file permissions that's important to look at is the permissions of the data directory. When I say data directory, I mean the directories containing the things like databases or folders from which files are shared. This data is accessed by the critical service during its runtime, meaning like as it's being run, and is important to the service's function. So this could be data that's sometimes served to the user. For example, in the case of a web server, the public root directory, such as var www.html, whatever is being accessed by the actual process, the actual executable, should be accessible by the daemon user, meaning the user that the critical service is actually running as. This is to ensure that extraneous file editing from other users on the system that aren't privileged is not possible. Oops. For the final part of system configuration, it's important to reduce user-facing debug information for a critical service. Now, I'm talking about the error messages that might be shown on customers on websites that might display the exact place in the code where something went wrong or the exact software version. You might have seen this before at some point. However, this is because this is sort of an issue. Because it allows attackers to know, for example, the exact software version that a critical service is running, and that might be able to help them identify vulnerabilities. Now, if you're running old software, like for example, an old version of Apache, for example, there do exist vulnerability databases such as the CVE database that I've linked right here that have lists of vulnerabilities on old versions of software. And obviously, the only reason why software gets updated is to, well, one, add new features, and two, address these vulnerabilities. So if you are known to be running an older version of a software, then a attacker basically has a red carpet into your system if there's an existing vulnerability that hasn't been remediated yet for that version. So just be aware of that. And essentially, the idea is that externally, you really don't want to show basically any debug or error information to your users as little as possible. You should give any potential attacker as little as possible to work with. But internally, it's important that we log these error messages to ensure that the server is always up and running properly. And let's go a little bit deeper into logging. So really the idea of logging is you want to have the highest verbosity, meaning like the highest level of detail level of logging within your critical service or application. Now, not to be confused with debugging, logging actually writes error messages and other connection information such as like an IP that accessed your system or like what resource they decided to access, like what subpage in a website, for example. Um, Essentially, it's super useful for like let me quickly emphasize the difference between debugging and logging before I move on. The logging actually writes these error messages and other connection information to files on the physical server where the critical service is running and is hidden away for user and customer view. So do not get this confused with debugging information. But yeah, logging is super critical for responding to potential service crashes, failures, or even complete cyber attacks. They provide sort of a trail for us incident responders to follow and find a potential criminal. It is worth noting that most log files are automatically stored in directories called log or logs under the service's data directory, but this can often be configured to customize the behavior somewhere in the configuration of a particular service. Overall, it's just a good idea to apply the same ideas that we talked about regarding configuration file permissions to these log files. They should really only be accessible by the super user, but also writable by the daemon user. So, of course, the process corresponding to your particular software is able to write to these logs. All right, that was a lot of information. I really hope you caught all that. If not, feel free to backtrack or let me know if you missed anything in the comments or in the brand new Discord server. Um, my advice to you, just keep in mind the following rules of thumb. Externally, your service should have as few entry points as possible. Give the attacker as few crevices to creep through as possible, whether this be an outdated TLS version, a super user account login that might be available, or even verbose debug information. Your goal should be to tighten your defenses as much as you possibly can. And internally, it should sort of be the opposite. You should be ready for an incident to happen, and to do that, you want to dump as much logging information as you can, but only visible to you. Now, again, this logging information and pretty much everything else on your server that's actually running the software should abide by the principle of least privilege. Again, I've linked a definition here, but the idea is that your service should basically it should be isolated in doing exactly what it's meant to do and nothing more. Um, but yeah, my final advice to you, I think, is really to put all these principles in action and find a new critical service like a web browser like Nginx or even a remote access tool like X2Go and just apply these principles. Just harden the service on a real image and develop configuration files that you can use during cybersecurity competitions. After all, practical experience is what wins championships, and trust me, I know a thing or two about that or four. I really hope this video helped you out though. Since this presentation was more of an actual slideshow, feel free to use it as teaching material for your own club if you'd like, as long as you attribute Linux Visually channel. And again, just join the new Discord if you'd like. I'll be sending out more updates there, and you guys can also request what you want to see. Thank you guys for watching. This will hopefully be one of the most impactful presentations you'll see and be applicable to just about any critical service that you encounter. So yeah, thank you so much, guys. Hope you enjoyed that.